Good morning everyone. This is the third part of MCQ of number theory. Yes, so first MCQ. I have uploaded already two parts of MCQs on number theory. So third part is, so first MCQ. If the GCD of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is, so there are four options and we have to find correct one. Yes, so use Euclid lemma here. What is GCD of 117 and 65? Obviously 13. Yes, so we can express GCD is as a linear combination of 117 and 65, means we can express 13 as a linear combination of 117 and 65. So we can write linear combination 117m plus 65n. Yes, but GCD of 117 and 65 is 13, so we can express we can write 13 is equal to 65m minus 117. Here we have not written n because they have given in question. What we have to write linear combination like this, 65m minus 117. Yes, so this negative 117 to take to LHS, it becomes positive. So 130 is equal to 65m, m is equal to 130 by 65, so m is equal to 2. So option 1 is the correct option. Yes, so second question, second MCQ. What is the remainder when 2 to the power 20 plus 3 to the power 30 plus 4 to the power 40 plus 5 to the power 50 plus 11 to the power 7 is divided by 7? So observe that here 7 is a prime number and here 2, 3, 4, 5, 11, all these numbers are relatively prime to 7, means GCD of all these numbers with 7 is 1. Yes, so we use here Fermat's theorem. So what are the options? Option is 2, 4, 5, 0, 36, 0 and 3. So which one is the correct? Now let's find. Yes, let's find. See what they have given. See, 2 to the power 20, we have to find modulo 7. What is the remainder? Yes, use Fermat's theorem. Use Fermat's theorem. Yes, for Fermat's theorem what we want? A to the power p minus 1 is congruent to 1 mod p. Yes, so a to the power p minus 1, a to the power a, here a is equal to 2 and p is equal to 7. So we write 2 to the power 7 minus 1 is congruent to 1 mod p. P means 7. So 2 to the power 6 is congruent to 1 mod 7. We want 2 to the power 20. We got here 2 to the power 6. So 2 to the power 6 into 2 to the power 6 into 2 to the power 6 into 2 square is congruent to 2 to the power 6 is congruent to 1 mod 7. So 1 into 1 into 1 into 2 to the power 2 modulo 7. Yes, okay, so which is congruent to 4 mod 7. So 2 to the power 20 is congruent to 4 mod 7. Call this as equation 1. Next we want 3 to the power 30. So 3 to the power 30 is congruent to which number? Modulo 7. Yes, easy one. See, here p is 7 and a is 3. Yes, p is 7 and a is 3. So 3 to the power 7 minus 1 is congruent to 1 mod 7 by Fermat's theorem. By Fermat's theorem. Okay, so you get 3 to the power 6 is congruent to 1 mod 7. Yes, so take 3 to the power 6 to the power 5, which is congruent to 1 to the power 5 mod 7. 3 to the power 30 is congruent to 1 mod 7. Yes, call this as equation 2 because in example we want 3 to the power 30. That's why we take fifth power of 3 to the power 6. Okay, next is 4 to the power 40. So how can we calculate 4 to the power 40 mod 7? 4 to the power 40. Yes. So first of all, 4 GCD of 4 and 7 is 1. For Fermat's theorem we want GCD of 4 and 7 is 1 and P is 7. P is prime. Yes. And 4 does not divide 7. Okay. So we apply Fermat's theorem. We apply Fermat's theorem. So 4 to the power 7 minus 1 is congruent to 1 mod 7. So 4 to the power 6 is congruent to 4 to the power 6 is congruent to 1 mod 7. Okay. So on next page, 4 to the power 6 and we want 4 to the power 40. Yes. So 4 to the power 6 is congruent to 1 mod 7. 4 to the power 6 to the power 6 is congruent to 1 to the power 6 mod 7. So 4 to the power 6 into 6, 36 is congruent to 1 mod 7. So 4 to the power 36 into 4 to the power 4 is congruent to 4 to the power 4. Means 4 to the power 4 is what? 16 into 16 mod 7. So here 4 to the power 40 is congruent to 16 means what? 2. Yes. 7 into 2 14. 16 minus 14 is 2. 2 into 2 mod 7. So 4 to the power 40 is congruent to 4 mod 7. Call this as equation number 3. Yes. Next we want 5 to the power 50. 5 to the power 50 is congruent to which number modulo 7. So again here GCD of 5 and 7 is 1 and 5 does not divide 7. So we can apply Fermat's theorem. Yes, we can apply Fermat's theorem. Yes, we can apply Fermat's theorem. So 5 to the power 6 is congruent to 1 mod 7 by Fermat's theorem. So 5 to the power 6 into which number which is closest to 50. So take 8 which is congruent to 1 to the power 8 mod 7. So 5 to the power 48 is congruent to 1 mod 7. Yes. So 5 to the power 48 and we want more 2 in 48. So we will get 50. Yes. So 5 square is congruent to 1 into 5 square mod 7. So 5 to the power 50 is congruent to 25. 25 and 25 is congruent to 4 mod 7. So you get 5 to the power 50 is congruent to 4 mod 7. All this is equation 4. And next we want 11 to the power 7. Yes. So 11 to the power 7 is congruent to which number modulo 7. So 11 here GCD of 11 and 7 is 1 and 11 does not divide 7. So apply Fermat's theorem again. Yes. So see 11 to the power 6 is congruent to 11 to the power 6 by Fermat's theorem. 11 to the power 6 congruent to 1 mod 7. Yes. So 11 to the power 6 into 11 is congruent to 1 into 11 mod 7 and 11 mod 7 is 4. So 4 mod 7. So this implies 11 to the power 7 is congruent to 4 mod 7. Call this as equation number 5. So adding equation 1, 2, 3, 4 and 5, you will get 2 to the power 20 plus 3 to the power 30 plus 4 to the power 40 plus 5 to the power 50 plus 11 to the power 7, which is congruent to what is remainder? 2 to the power 20. So observe equation 1. 2 to the power 20. 2 to the power 20 is congruent to 4. Equation 2. Here 1. Yes. So 4 plus 1 plus observe equation number 3, 4 to the power 40 is congruent to 4 mod 7, and observe equation number 4, 5 to the power 50 is congruent to 4 mod 7, so 4 and 4, so 4 plus 4 plus 4 modulo 7. Yes, so you will get 12 and 13 mod 7. So what is remainder? 4 plus 4 plus 4 plus 4, 17 modulo 7. So 7 into 2 14, so 3 mod 7. So you will get remainder is 3. Remainder is 3. Yes, see, remainder is 3. So option D is the correct option. Option D is the correct option. Yes. Next example. Apply Chinese remainder theorem to solve x is congruent to 3 mod 9 and x is congruent to 7 mod 13. So there are 4 options. X is congruent to 107 mod 117, x is congruent to 103 mod 117, x is congruent to 111 mod 117, x is congruent to 105 mod 117. So which one is the correct option? C. They have given 2 congruences. Yes. So this is A1 is 3, A2 is 7, M1 is 9, M2 is 13. Okay. So GCD, for applying Chinese remainder theorem, GCD of M1 and M2 or GCD of Mi must be 1, means all Mi's are relatively prime. Then and then we can apply Chinese remainder theorem, otherwise not. So here GCD of 9 and 13, there are 2 congruences. So GCD of 9 and 13 is 1. If there are 4 and 5 congruences, so GCD of each pair of Mi must be 1. Okay. So find capital M. Capital M we can write M1 into M2, product of M1 into M2. So M is 117, that is 9 into 13. Yes. So you will get M1 is equal to M upon small m1, M2 is equal to M upon M2. So we calculate here M is 117 by 9, that is 13. M2 is 117 by 13, that is 9. Yes. In next step we find inverses, means we write always such type of equation. Capital Mi into Xi is congruent to 1 mod Mi. So M1 X1 is congruent to 1 mod M1. What is M1? M1 is 13. We have found this value. Yes, 13 into 7 is congruent to 1 mod 9. So find value of X1. Find value of X1 such that the product gives answer 1 modulo 9. If we put here 7, yes, so 7 into 13 is, yes, and go to modulo 9, you will get answer X1 is equal to 7. Likewise here if we put X2 is equal to 1, we will not get 1. If we put X2 is equal to 2, again we will not get 1 here. If we put X2 is equal to 3, so 9 into 3 is 27. 27 modulo 13 is 1. So X2 is 3. Find inverse. Yes, and the final solution you will get like this. X is congruent to M1 X1 A1 plus M2 X2 A2 mod M. Yes, so X is congruent to 13. Put value of M1 X1 A1. We have solved all these 3 values, M1 X1 and A1, M2 X2 and A2. Put all values and calculate, you will get answer X is congruent to 111 mod 117. Yes. See. Next MCQ number 4. Yes. What is the remainder when 3 to the power 31 is divided by 7? Very simple. Here they have given 7. 7 is a prime number. Yes. And here is 3. So GCD of 7 and 3 is 1. So we can apply Fermat's theorem. Yes, so what is Fermat's theorem? A to the power p minus 1 is congruent to 1 mod 7. Put here value of p and a, calculate, you will get remainder is 3. We have solved in example number 2, how to find remainder. Yes, so you will get remainder 3. So option 3 is the correct option. Yes. MCQ number 5. The square of any positive integer is of the form. We have already learned in class. Yes, what is square of any positive integer is always of the form 3p or 3p plus 1, where p is any integer. There is no condition that p is odd integer or p is even integer. Yes, so answer option 3 is the correct option. Yes,